Hello everybody, this is Miss Nyman. This is Unit 7, Solutions in Acid-Base Chemistry. We're in Section 6, which is all about naming acids and bases. So I just want you to take notes on this in your notebook or wherever you take notes, but you should also have a practice sheet in front of you for the practice of naming acids and bases. On the back side of that practice right now is the answer key. What I don't want you to do is just check back and forth between the answer key and the naming, because you're going to end up not actually practicing and you're just going to kind of write down the answer key, and that's not particularly helpful because you do really need to know how to name these. They'll be on quizzes and tests and things like that later on, so make sure that you know these rules and that you are well practiced at these rules. So we'll start off with acids. So acids, we know that they can release hydrogen ions, but depending on what type of acid it is, they will release different numbers of hydrogen ions. If there's only one hydrogen ion there, like HCl, we consider that to be monoprotic. It can only release one hydrogen ion because it only has one hydrogen involved. Then we look at a diprotic, which would be H2CO3, which is carbonic acid, or sulfuric acid, H2SO4. Those are our most common diprotic, and I'm calling it di because there are two hydrogens in both of those. Triprotic, the most common one we're going to talk about with triprotic is phosphoric acid, which is H3PO4, and it's called triprotic because it has three hydrogens. So I'm going to reference these terms monoprotic, diprotic, triprotic quite a bit, and they're going to be really important to our future calculations. For bases, the bases are named based off of, well, not named, but they are categorized based off of how many hydroxide ions there are. Remember that not all bases have hydroxide ions, so this is really kind of an old school way to categorize bases, but if there are hydroxide ions, whatever you are talking about is a base, so this is still valid enough to talk about. And again, it's just based off of how many. We have one hydroxide, therefore it's monobasic for sodium hydroxide. For magnesium hydroxide, we have two of them. Calcium hydroxide, that should say 2, and it says 3. Oopsies. That should say 2 right there. CaOH2, that would be 2 hydroxide ions, which would be dibasic. And the last one, AlOH3, has 3 hydrogen. Nope, that's none of them. 3 hydroxide ions, which would be tribasic. So naming of the acids is the most complicated. Bases are really, really easy. The acids, you have to follow a couple of rules. We'll start with simple binary acids. They're called binary acids because they only have 2 elements in them. Only 2 elements. There we go. That would be your HCl, your HF, your H2S, your HBRs, anything where it's only a hydrogen and one other element. Involved is a binary acid. And those are the simplest to name. It's just hydro as your prefix, then you do the root, sulfur, chlor, brome for bromine, and then you end it in ic. So hydrochloric acid, hydrobromic acid, hydronitric acid, hydrofluoric acid, any of those. That's the simplest one, and you guys should already, I don't know why this is moving, you guys should already know a few of those because we reference HCl a lot as being hydrochloric acid. That's the easy one. On the other side, we have a category as oxyacids. Now, oxyacids are really just everything else, and it contains the polyatomic ion. It's an acid with a polyatomic ion. So we can have sulfate, carbonate, chlorate, iodate, bromate, bromite, hypobromite, any of those things you're going to consider to be your oxyacids. We're going to stick with the polyatomic ions that ended in ate and ite when we're making our acids, just to kind of simplify things down. So if your polyatomic ion ended in ate, then you're going to just change the ending to ic. So I like to remember this as I ate an icky bug. and that's kind of how I remember ate to ick. And then ite goes to OUS. Ate, ick, ite, us. The difference, but this is a very small discrepancy, but the difference is a big deal. So, for example, hydrosulfuric acid is H2S. I know it's H2S because it has the hydro, and therefore it's only 2 elements. But sulfuric acid doesn't have hydro in front of it, and it ends in ick, which means that it was based off of the sulfate ion. And if it was based off the sulfate ion, I need 2 hydrogens in order to cancel out that charge over there on the right. Let's see if I can't really erase that. But to cancel out this charge, I would need 2 hydrogens. So these have very similar names, but they are very different species. So it's really important that we know what species we are talking about. I ate an icky bug, or ite, us, ate, ick. Make sure you remember that in some way, shape, or form. Make yourself a different mnemonic if you want. Okay, the last one is bases. We have strong bases, which generally contain hydroxide, and therefore they can generally bond with alkali or alkaline metals. And those are pretty simple. Just name them same way you would name an ionic compound. Barium hydroxide, sodium hydroxide, calcium hydroxide, potassium hydroxide, lithium hydroxide. That's all normal. Weak bases often have covalent compounds, and therefore we would use our covalent naming system. The most common one we're going to see here, we actually use the common name of. So technically NH3, which we've been referring to as a base, is called nitrogen trihydride, but the common name for that is ammonia, and we've all heard of ammonia. So that's typically what we end up calling it. But technically any sort of weak base would be considered covalent, and therefore you would use covalent naming practices for that. So at this point, you know all of the naming styles. You should be able to go through and work through that practice worksheet, and that is due next class.